Okay, so the angle bisector cuts the angles in half. So that means that those two angles are congruent, which makes it an easy equation. 4x is equal to 32. If I divide 32 by 4, x is equal to 8. And that's all we were trying to find is the x. Okay? Now let's look at the number 2's. All these are about isosceles triangles. That means that the base angles and the sides are equal. The angles that are equal to the side or across from the sides are equal. Okay, so this one, these two are going to be equal. So I'm going to be 6x minus 1 is equal to 77. Okay, and I know those two are equal because the two sides are equal. Now when I solve this, I just 6x, I add 1 to both sides, so that makes this 78. And x is equal to 13. And that's all. Again, all we're doing is solving for the variables. This one's solved for y. Now, yeah, these are isosceles triangle that we're looking at, but I also have to remember that all three of the angles add up to 180 degrees. So this is just an equation, 3y plus 2 plus, I could do 65 plus 65, which is 130, and all that equals 180. Now I'm going to combine like terms, so that's going to give me 3y plus 132 equals 180. Okay, in order to solve this, I've got to subtract 132 from both sides, and that's going to give me 3y is equal to 48. Okay, now if I divide both sides by 3, I get 16. Okay, and the next one, this is an isosceles triangle, because I see these two here. Now, that means that this angle is congruent to this angle. Y is not congruent to these other two angles. So now I need to remember that these two angles right here are equal to 180 degrees. They're a linear pair. So I've got 180 minus 150. That's going to equal 30. So that goes right there. Okay? Which means that x is also 30 because the angles opposite the sides are going to be congruent. Now, so that gives me my base angles are 30. So I've got y, and remember all of them add up to 180, plus 30 equals 180. Combine these two terms, I've got y plus 60 equals 180. And then I just subtract 80 from both sides, and that gives me 120. Okay, number 3 says that AD is the median. So the median is going to cut this in half. It's cutting BC in half. So that means that BD is equal to DC. So the way that I'd solve this, 2x plus 5 is equal to 3x minus 2. Okay, and I'm going to subtract 2x from both sides because I want a positive x. You could have gone the other way. It doesn't matter. Okay? So 2 minus 2 is 0. So that leaves me with 5. 3 minus 2 is x. And then I have to bring down the negative 2. And then the last thing I have to do is add 2 to both sides. Okay, 2 minus 2 is 0. So x, that comes down, is equal to 7. So we needed to find x, and we did that. And then we needed to find BC. So I need to plug in 7 into both of these x's. Okay, so that gives me 2 times 7 plus 5. Now I'm doing the whole thing, right? It's the entire equation, so, or the entire segment. So I'm going to have to plug it into both sides. Plus 3 times 7 minus 2, and that's going to equal, it's going to equal 38. So BC is equal to 38. Okay, on number 5, it's a perpendicular bisector. This is going to be in two different pieces. So that is an equation on its own. You're going to find y, and then you're going to find x. The two are not related, okay? The perpendicular part means that this is equal to 90 degrees. The bisector part means that these two are equal. Okay, so you're going to do two different equations. I'm going to have 5y is equal to 90. If I divide both sides by 5, I get 18. And that's one answer. Okay, that doesn't have anything to do with the bottom one. So the other equation is going to be 3x plus 9 equals 99. If I subtract 9 from both sides, that gives me 3x is equal to 90. If I divide by 3, x is equal to 30. So those are the two answers, and they're not related. Okay? Okay, the next side, it says, name the special segments. So this first one, A, it's a line that's dropping from the vertex straight down to give me a 90-degree angle. So this is an altitude. It's not a bisector, it just drops down. This is basically the height of the triangle. Okay, so that's the height of the triangle. B is going to be an angle bisector, and I know that because it shows me that these 2 points, it gives me those two arcs. So this is an angle bisector. Okay, C doesn't tell me anything about the angles. The only thing it shows is that it is cutting the opposite side in half from where it started. So if it goes down this way, that means that it cut it in two pieces. So this is the middle. So you need to remember that this is called the median. That's the name of that, okay? So the name of that segment's called the median. The next one is a perpendicular bisector, and we know that because it drops down and creates a 90-degree angle, because I have the square, and it created two congruent segments. So this is a perpendicular bisector. Okay. And number 10, what are we doing with number 10 here? It says, correctly name the second triangle, then identify which theorem you could use, if any, to prove the triangles. So it's telling me that this is going to be triangle ABC. So I've got to think about how I'm going to say this because it has to be in the right order. So I'm going A, B, C, and I'm away from the sides that are congruent. So I'm starting at X, and if I go to B, so if I look back at here at B, okay, B has the single tick mark by it. So I'm going to go X, Y, and then Z. So this triangle has to be set up as X, Y, Z. And that's going to be by side, angle, side. Okay? And then we have this next one, RTS. I'm going to go from the long side, R, to T, and then to S. So if I do this side, I'm going to go from the long side to the middle, to T, and then to V. So this is UTV. It has to be in the right order. Now, remember, the middle angles are vertical angles. They're never going to be given, but they're automatic. As soon as you see vertical angles, they're going to be congruent. So this is going to be congruent by angle, angle, side. Okay? And then we have this next set. it shows me that I've got a right angle. So the first thing I need to think about is HL. But if I'm going to have HL, the hypotenuses have to be congruent. And they are. So this is going to be by HL. Okay, now, how am I going to identify the triangles that are congruent? So here's what I looked at. A starts at the right triangle, or the right angle, and I'm going to go to B, so that's the short side. So this is going to start at the right angle, and I'm going to go to Y, the short side. So X, Y, Z. Okay? I have to make sure I go in order correctly. Remember, that lines up, AB is going to be congruent to XY, and it has to show that. It has to be in the same order. All right? Then we have ABC. So if I look at ABC, I go from A to B, so that's along the tick mark that has one tick mark. So that means that I'm going to go at C along one tick mark, and then I go second tick mark. So I go second tick mark. So this is going to be DA. So ABC is to CDA. ABC, CDA. Okay? And then it showed these two lines and those two lines were congruent. And remember, the middle piece is always congruent by the reflexive property. So this is going to be CDA or ABC is congruent to CDA by side, side, side. Okay? Now let's look at the next one. All right, there's a lot going on in this one. So it says in diagram below, ABC is congruent to XYZ. I remember when we do these statements, the statements are set up so that we can tell what's equivalent to what. If I look at this, it tells me that A is congruent to X as far as the angles go. So I'm going to mark an arc in there, X and A. And it shows that B is congruent to Y because they're in the same spot. So these two are congruent. And then it tells me that C and Z are congruent. So C and Z are congruent. Okay? It also does the same thing for sides. But right now we're just dealing with angles. All right, so let's look at this. I'm going to erase this so we can see what we've got. Okay? All right, A is congruent to X. That means that X, so the measure of angle A is 67. It tells me that. It doesn't give me the measure of angle B, but I do know that B is equal to Y. It doesn't give me the angle Y, but it does tell me that the angle Z is equal to C. So this is going to be 53. Now, the way that I find here, it's asking for the measure of C. It's 53. So how do I find the measure of B? Well, they all add up to 180. So 180 minus 67 minus 53. So that's going to be equal to 120. That's 60. Okay? All right. And let's see, it tells me that it didn't give me a measure, but it asked me what segment AC is equal to. So all I have to do is look at this, A to C, X to Z. And then CB, so here's CB, is XY, or ZY. Always trying to keep it in the same order. For this side, it says, for each pair of triangles, state which theorem, if any, could be used to prove them congruent. Hint, remember to look at reflexive side, which is that piece that's always shared. So I'm going to mark those on all these that I can see. And that's all the reflexive sides. And then the vertical angles are the angles that are made when I cross each other. So right there is a vertical angle, and right there is a vertical angle. All right, now we can look at this and see. Now, I know that this first one doesn't have an arc, but it's a square, which means that those are still both equal to each other. This is 90 degrees, and this is 90, and this is 90. So this is going to be side angle, side. And then on this one, there's 3 sides that are congruent. So I've got side, side, side. On this one, I have angle, side, side. So this is none. Remember, we don't have that one. And this one is angle, angle, side. All you're doing is matching up your images. Angle, angle, side, side, angle, angle. So this is an angle, side, angle. And then this one, it's 3 angles. So angle, angle, angle is none. We don't have an angle, angle, angle. All right? And then we have this next one. I've got side, angle, side. Side, angle, side. And this one's going to have angle, side, angle. And then this one, again, angle, angle, side. Whoops. Angle, angle, side. Okay, number 13 says mark the diagram and state which congruent statement or theorem could be used to prove the triangles. So JK is congruent to NK. They marked that for us already. Okay? A is the midpoint of JN. Okay, so that tells me something different. That tells me that those 2 segments are congruent. And then I have the that middle piece that's always reflexive. So this is going to be congruent by side, side, side. Okay? And then this next one says mark the diagram and state which congruence theorem could be used. Okay, they didn't mark anything for us. So I'm going to immediately mark my middle segment that I know that's congruent. And then it tells me that QK, so there's QK, is congruent to QA. And then it tells me that QB, so QB is this line right here. It bisects the big angle, KQA. Here's KQA, so it bisected that angle. So that means that KQB is congruent to AQB. So this is going to be congruent by side, angle, side. Now, the last 2 things we have to look at, it says classify the following triangles' lengths as acute, right, or obtuse. So remember with these 2, you have to do C squared, which is the longest side, and you have to do A squared plus B squared and see which one's bigger, okay? If C squared is bigger, it's obtuse. If C squared is smaller, then it's acute. And if C squared is equal, then it's a right triangle, okay? So if I look at this one, I've got 10 squared, that's C, that's equal to 100. Then I've got 5 squared, so I have 5 squared plus 6 squared is going to be equal to 5 squared is 25, 6 squared is 36, so 25 and 36 are equal to 61. So C squared is bigger, so this is acute, this is obtuse. Okay? All right. I'm going to start over because this is going to get just kind of all messed up and I don't want to get all jumbled up. So here we go. C is the 41. So I have 41 squared, and then I have 9 squared plus 40 squared, okay? So Okay. 41 squared is 1681. And then 9 squared plus 40 squared is also 1681. So they're equal to each other, which means I have a right triangle. So this one is a right triangle. Okay. Okay, C is 11. So 11 squared is equal to 121. And then I've got 9 squared, which is 81, plus 10 squared, which is 100. So this is 181. So this one's obtuse. Okay. All right. And then I've got 6 squared. So 6 squared is equal to 36. And then 3 squared is 9, plus 4 squared is 16. So that equals 25. So C squared is bigger. So that's another obtuse side. All right, now the last one, 16, which would not form a triangle. Remember, any two sides, the sum of any two sides, okay, so the sum of any two sides must be bigger than the third side. Okay? So if I look at each one of these, I can take this one for example. D. 5 plus 8 is 13. That's bigger than 8. Okay? 8 plus 8 is 16. That's bigger than 5. Okay? And then, so that was going to make a triangle. Then I would have to take a look at the next one. I'll go back to A. This is the one, let's see, which one is not bigger? B is the one that's the answer, because we want not. If 8 plus 10, or 8 plus 10 is 18, 19 is bigger than 18, so this doesn't work. So B would not be a triangle.